After closing switch, so how the circuit will be? First we'll take the 3E, this is E, this is a capacitance, and this is a capacitance 2C. I'll assume a charge Q1 minus Q1, here Q2 minus Q2. Let's find out the charge. Any isolated junction? Any isolated junction? So look at this, this particular charge of these two plates must be conserved. It's a very good problem, a very good simple problem. It's available in book without initial charge. It's very easy. If I just bring initial charge, little bit interesting it will become. Look at this, shall we call this as isolated junction? No, you see that. Again, you have connection here, no? So this is not isolated junction. What about these two plates? Is it isolated junction? No. Again, you have here. So therefore, we don't have any isolated junction. Okay, we are safe. We are safe. So let's write the KVL equation. So plus 3 minus Q1 by 2C minus E equal to 0. So Q1 equal to 4CE. Similarly, we'll go for Q2. Q2, I'll write only loop equation here. So this should be plus C minus Q2 by C equal 0. So Q2 equal to how much? CE. These are the charges. So here we need in any initial, any energy is present. Yes, there's some energy is present in the circuit. So what is that initial energy? UI equal to Q naught square by 2C. Or Q naught equal to how much? C. So this will be C E square by 2. This is the initial energy in the circuit. Initial energy in the circuit. Then final energy in the circuit. Q1 square by 2C, Q2 square by, this is 2 into
So that
2.
is E square by 4.
Which one?
Initial energy.
Q naught is C, no? Okay, so 2 into, this will be 4. 2C, no? Capacitance. Okay, thank you. This will be Q1 is equal to 4C, no? 16 by 4. So this will become 4C square. Q2 is CE. This will be C square by 2. 9 CE square by 2. Now, how to calculate the work done by the cell? So take help of this. Look at this plate. I'll give the plate name P1. What was the earlier charge? Minus Q naught. For that, we'll assume that some charge flown here like this. QA charge. So therefore, at plate P1. What was the earlier charge? Minus Q naught. This was the plate P1. Minus Q naught. Then plus QA charge entered. And finally, it has become Q1. QA we don't know. Q naught is how much? Minus CE. Q1 is 4C. So how much of charge? 5C. Similarly, I want the charge flown through this battery. I don't know whether it does positive or negative work. So here, if I go for tracing out charge, charge will be like this, QA. This should be QA. Let's take help of plate P2. Let's take help of plate P2 at P2. See, these things you find very difficult because you don't have any formula. You have to make observation. Solve some 4 or 5 problem, the method you'll understand, finish over, nothing big. Different cases you take it out, it'll be easier. Okay, plate P2, what was the initial charge? It was 0 plus. What shall I do now? Shall I assume positive charge, negative charge? You look at this one. 0 charge it was there. Earlier that plate P2, 0 charge. Now it has become minus Q2. So some charge might have left, some positive charge left. So here I'll assume like this. QB charge, let it come here. Some QB charge left here. So therefore, minus QB, I'll write it. Why negative? Because charge left. Sir, I'll assume charge entered. Okay, no problem. Solve it. Positive charge. So positive charge left. So therefore negative. Are you getting this one? Or else what you should do? Negative charge entered. I think both are same, no? Or directly you can tell it some earlier 0 minus Q2. So how much of charge? So if I solve it, I'll get QB equal to how much? QB equal to QT is how much? CE charge. I got positive. What does it mean? Some charge left. Positive charge only left it here. Then QA we got it. So here, what is QA value? 5C. Here C is there. So what charge should come from here? Some Q naught I cannot assume. So QC I'll write it. QC, let it be QC. So QC plus QB should be equal to QA, no? Because QA value is how much? 5C is there. So QB is how much equal to C is there. So applying conservation of charge at that junction. So we'll get the equation QC plus QC plus QB equal to QA. So QC should be equal to 4C. Now we have all the information. So what about here? S, you can bring it the same idea that QA charge will come if you want to further continue. In that, QB will be like this. Like this, we should, to trace out a charge in a branch whose help you have to take, you have to choose either positive or negative plate. Say I just took intentionally plates like this. Earlier I took positive plate. Here this one. Here I took negative plate. It's not that only you have to take positive plate. You can pick up any plate here. So now let's go for what about this cell? This supplies energy, no? This cell supplies energy. What about this? This stores energy or stores, you write it. Stores means negative work. So now what is the expression for? We'll write expression for the energy, that one, heat generated in the circuit. So initial energy. Before that, work done by the cells. Okay, we'll first write that equation. Initial energy plus work done by the cell E, work done by the cell 3E equal to UF plus heat generated. Initial energy, we know C square by 4. Work done by cell E. It does negative work, no? Minus QC into E. Why negative sign I should take it? It does negative work. Then this will be QA into 3 equal to, this will be 9 CE square by 2. Substitute QA QC value, solve it, you'll get the heat generated. Okay, there's a method of there's a heat generated, so solve later on. So like this, you'll get a numericals where they'll ask you about the heat generated. Completed. I'll take the next one. Let me do one problem again on nodal analysis.